guys, hope you're doing great. Our today's question is shortest unsorted continuous subarray. Given an integer array, you need to find one continuous subarray that if you only sort this subarray in ascending order, then the whole array will be sorted in ascending order too. You need to find the shortest such subarray and output its length. So for example, here the given array is this. So the output is 5 because if we sort 6, 4, 8, 10 and 9 in the ascending order, then 2 and 15 are already in their globally sorted positions, and that is why the answer is 5 because that is the shortest subarray that we need to sort, right? So subarray means it's like a continuous subarray, which does not mean any random elements from anywhere in the array. It means like a continuous set of elements in the array, right? Okay, so yeah, the length of the input array is in this range 1 to 10,000. The input array may contain duplicates, so ascending order here means less than equal to. All right. So this question is um, a slightly tricky one because we cannot just use a sorting algorithm to sort all of them, and get the answer. That would not be a very good solution if we try to like sort it and then track each element where it was and then find out what is the minimum number of elements we had to sort. So that will be high on the time complexity and space complexity both. And if we were to find a solution which does not have that much, we just have to apply some simple basic logic here, which is that we have to find that first element, right? Which is the beginning of the unsorted array, and obviously the last element, which is the end of the unsorted array, or the sub array which we have to sort in order to make the whole array sorted, right? So now since we want to sort this entire thing in ascending order and the answer depends on that, to find that first element, what we have to do is that if we are saying that um, this has to be sorted in the ascending order, we traverse the array from the left to the right and find that first element, or we can call it like a dipping point, where it's not in the ascending order, right? So for example, 2, 6, this is in the ascending order, but as you can see, 6 drops down to 4, which is not the ascending order, right? So we find that minimum value which we are able to encounter in this way. So like 6 and 4. Okay, so we record 4, right? Then 4 and 8 are in the ascending order, 8 and 10 are in the ascending order, but 10 and 9 are not. So the value after dipping is 9, but that's more than 4, right? So we don't bother recording that, or we don't update the minimum that we were recording. Similarly, we start from the right to the left and we find the first rising, or we find that rising value, right, which is not supposed to be the way it is, right? For example, if we talk about 15 and 9, so this is in the descending order, which is expected, so it's great. 9 and 10, this is not in the descending order, right? So we have to record 10 here, right? And we want to find the maximum value we can find in this way. Now this is in 8 and 10 are in the descending order, 4, 8 descending, 6, 4 are not, right? But then 6 is not greater than 10, so we just keep it 10 and that's it. So now we have found that 4 and 10 are those points where things start to go wrong in the array in terms of the sorting, right? So what we do is that we try to see that where will I have to place this minimum element and the maximum element, which are not in their right places, obviously, because of the order. Where do I place them? Where do I place this minimal element? And why it's necessary to record the minimum one is because because if there is any other element which is more than that, it will obviously come after that, and we only bother here to find that length of the subarray, right? So if I am to place 4 somewhere, it will obviously be placed before 6, and that is why that whole subarray would have to be sorted. So we don't care about bigger ones, right? So this minimum value, we start comparing it with the elements starting from the start, from the 0th index, and whenever we find a value which is greater than this, right? So let's say if we are searching for 6, right? So if we find, all right, no, we'll be, in this case, we'll be searching for 4, right? So 2 is already smaller than 4. It means it's already in its right position. But 6 is greater than 4, right? So that would mean that this is the index from where our subarray would start. And similarly, when we try to look for 10, like values which are more than 10, which are lesser than 10, right? So 15 is not less than 10, but 9 is, right? So it means 10 would come over here, and that is why this would need to be shuffled, and this is the end of the continuous subarray which we will have to sort, right? So that's how we find the two positions, and we just return the answer, that is the difference between them plus 1, because it's all index based. So let's try to implement this. It's very simple to implement, but it's a really good question. It helps think about the whole array problem solving in a very different way. So let's just get started. Okay, so as I said, we need to have a min, which will be integer dot. We want to initialize them with extreme values because we want them to be updated the very first time we see a value, right? So we just do the opposite. Okay, yeah. Now we'll travel through the array starting from 0, I less than nums dot length minus 1, because we'll compare it with the I plus 1 element, so we don't want to go index out of bounds. Yeah, okay. So now we have to check that if the nums of I, so we expect it to be in the ascending order, right? So if at any point I is greater than, nums of I is greater than nums of I plus 1, we have a problem, correct? Because that's not the ideal way in ascending sorted array. So we have to yeah, so we have to just update min with whatever is minimum of min comma nums of I plus 1. Okay, fine, that's all. After that, we'll start from the end, right? Nums dot length minus 1, and we'll go till I is greater than 0, not equal to, because we'll again be doing I minus 1, I minus minus. Okay, so here if, again, now since we are traveling in the reverse order, we expect it to be in the descending order. So if my nums of I should ideally be more than nums of I minus 1, but if it is less than nums of I minus 1, right, then we have a problem. So we just calculate max in a similar fashion. Sorry, math dot max of max comma nums of I minus 1. Yeah, okay. So now we have the min and the max values. Now we'll just compare, like we'll just again start from I equals to 0, I less than nums dot length minus, nums dot length, yeah, and I plus plus, okay. And we have to check that if nums of I is more than the minimum, right, then it means that it is not in the right place, okay. And just as we find an element which is more than the minimum, that means that it starts like that's the starting point of the continuous subarray that we'll have to sort, right. So we'll just record that. So let's take an L and an R, and we'll just yeah, so we'll just have to assign I to it, okay, and then break. So our search is complete for this. And similarly, we will also have to start for from the back, right. So we'll have to do a nums dot length -1, and I is greater than equal to 0, and I plus plus, I minus minus, and oops. So yeah, and just as we find that this element at nums of I is less than max, right, so then it's not correctly placed, right. Yeah, then R will be equal to I, and we'll have to break, and then finally we can return. So if my L, if R minus L, because R will always be greater, so if R minus L is greater than 0, okay, or maybe just equal to 0 as well, greater than equals to 0, then it's a R minus L plus 1, okay, otherwise it's a 0. So we don't want to return weird values, that's why. Okay, let's see if that works. Oops. Uh-oh. Yeah, we need to initialize them. Yeah. Okay. Oh. So I guess that's because we are using this. Shouldn't be. Yeah. Yeah. Okay. So the time complexity for the solution is O of n, because although we are traveling through the array 4 times, but it's still like n plus n plus n plus n, which gives us an O of n. And the space complexity, it will be O of 1, because we are not using any extra collection, just 2 or 3 variables, which is still a constant. So I hope you guys enjoyed this video and find it really helpful. If you do, please like, share and subscribe. Keep coding. Take care, guys.